Okay, we did some work with direct measurement before we took the Florida Math League contest. I should have said indirect measurement. We indirectly measured the height of some tall trees out on the field by using a partner's height and measuring distance to the partner, distance to the tree, height of the partner. This problem's a similar situation. The world's tallest man lived from 1918 to 1940. He cast a 4-foot, 9.5-inch shadow at the same time of day when a 6-foot pole cast a 30-foot shadow. How tall was he? So we're comparing height of the person and height of the pole. So we're comparing the height of the object to the length of the shadow. And the shadow lengths are given in well, this one's given in feet, but this one's given in feet and inches. It's best not to have a mixture of units here. So 4 feet multiplied by 12 inches per foot. We're going to talk about dimensional analysis soon. You can see the feet cancel here, feet over feet. It's just like any kind of common factor would cancel out. Units cancel as well. And so 4 feet is equal to 4 times 12, or 48 inches. And when I add that to the 9.5, we get 57.5 inches for the man. For the length of the shadow. So let's just keep the length of the shadow in inches just to keep it simpler. So this 3-foot shadow is 36 inches. We can keep the It's hard to say whether we should make the height feet or inches, because what are the chances that the man's going to be exactly some whole number of feet? And if we get a decimal answer for feet, that's not easily converted into inches, since inches are twelfths and not tenths. So I'm sort of leaning towards also representing the height in inches. This is the length of the shadow for the pole. The height of the pole would be 6 times 12, or 72 inches. And then this 57.5 inches is not the man's height, it's the length of his shadow, 57.5. The height of the man is x, and now, worst case scenario, now you could do a proportion and use a cross product equation to solve. But you might see something else, so why don't you try to solve that during the pause and come back and see how you did.
Paused.
There's a nice scale factor here. I think I'll actually write the proportion and show it a little better. 72 over x is equal to 36 over 57.5. Going this way is a scale factor of 2. So I can scale up this 57.5 times 2. I don't really need the traditional algorithm for this, right? Because 50 times 2 is 100. 7 times 2 is 14, and a half times 2 is 1 more, so it's 114 plus 1, or 115 inches for the height of the man. But since we typically, well, that's taller than I thought. Since we typically think of people's height in feet and inches, let's convert that to feet. I can show you this other thing by doing that. 115 inches divided by 12 inches per 1 foot. I'm showing you this so you can see that this idea of dimensional analysis also works when you're dividing with units, because we know dividing is the same as multiplying by the reciprocal. So this is 115 inches multiplied by, flip that bottom fraction, 1 foot per 12 inches. And so the inches cancel, and I'll just get feet. When I do 115 divided by 12, I'll get my answer in feet. It's almost 10 feet tall. That's crazy. Not quite 10 though. 9 multiplied by 12 is 108, and we get a remainder of 7. So 9 and 7/12 is a mixed number, but since we're doing feet, and since twelfths are every 12th is an inch, his height is 9 feet 7 inches. True story. You could look him up. I can't think of his name right now, but pretty tall guy. Okay.